So good afternoon, everyone. Hope everything is going well. Welcome to the MIDAS IT Australia Online Training Day 1. My name is Eric Choi, and I'm the account manager for Oceania here at MIDAS IT. I'm really excited to have you all here, whether you've been using MIDAS Civil for a while, or if this is your first time diving into Civil NX. So today's session will help you to get the most out of the software. All right, let's get started. Here's what we've got lined up for today and tomorrow. So today we'll focus on PSC Composite Bridge Design as per AS 5105. It's a hands-on training, so we encourage you to follow along as we go. Tomorrow, we'll dive into ANZ tailored plugin for Civil NX, walking you through how to utilize plugin we offered. So before we dive into PSC Composite Bridge Design, there's a few things that I'd like to share. First, here's a quick recap on download Civil NX. Go to MIDAS support site and login. Next, click product download. Then you will see the Civil NX button. Click on it. On the next page, click download general execution install. And please install Civil NX sequentially. Here's how to activate Civil NX. So when you open the Civil NX, click on Register Protection key right here. And you will see the screen like the one here. And there is a protection key for today's training displayed right here on the screen. So please go ahead and use that along with your user ID and password to activate the Civil NX. I'll give you a quick moment to enter or take a screenshot then now. All right, let's move on. So with the activation complete, now you have access to the 14-day free trial, which runs until Friday, March 14. So you will be able to explore everything from modeling, analysis, and design to trying out the upgraded UI and the marketplace plugins. So if you'd like to know more about the Civil NX, please feel free to reach out to me. Next, we send the training material for today's session, along with the reminder mail in this morning. So when you click the link in the mail, you will see the screen like this one shown above. Then simply click the download button to get all the materials at once. Our structural engineer Pranav will walk you through everything in real time, but don't worry if you fall behind. We have provided a PDF file so you can review the steps later. Also, the base MCB file has materials and section property preset to ensure smooth training. So for anyone who was not able to download this material, I'll share the link in the chat. Next, I want to quickly highlight that the MIDAS Civil NX 2025 version has been officially released. So if you have installed Civil NX specifically for today's training, you are probably working on the 2025 version. But for those of you who were already using Civil NX before this training, there is a chance you might still on an earlier version like Civil NX 2024. So I just want to make sure everyone is aware of the 2025 release, So if you have not upgraded yet and would like to, I'll share the link here as well. And finally, I'd like to share the news you've been waiting for. On April 2nd, we're hosting a webinar with Engineers Australia, focusing on practical study, case study using MIDAS FEANX. We'll dive into real-world application from complex structural analysis to advanced optimization technique. Plus, you will earn CPD hours. We'll be sharing more details soon, and I'll make sure to send them via email. So please keep an eye on it. All right, here is a quick overview of what we'll be covering today. We've already gone through the opening, so now I will walk you through what's coming next. Next, Pranav, our structural engineer, will guide you through the PSC Composite Bridge modeling and design process as per AS 5105, and we'll wrap up the session with a dedicated Q&A. Well, you will have a chance to ask questions you may have. And also, just a quick note, we'll have another training session tomorrow focused on plugins. We'll cover tools like the group pile plugin, PY curve plugin, and more. And the next training session will be led by Pranav, a structural engineer at MIDAS IT Australia. He is an expert in advanced analysis and has collaborated engineers worldwide optimize their project with MIDAS technologies. He's also had led training, webinars, and more, making engineering workflow more efficient. So without further ado, I'll hand it over to Pranav to get started on the PSC Composite Bridge Design. Pranav, please go ahead.
All right. Thank you, Eric. Let me just share my screen first and then we'll begin. I hope I'm audible to everyone. Can someone confirm if they can hear my voice and also see the screen which I'm sharing? Eric, can you confirm? You can hear my voice?
Yes, I can see your screen.
Okay, thank you. Okay. So good afternoon, everyone. My name is Pranav. I'm working as a structural engineer at MIDAS City, Australia. So our topic for today's hands-on training session is PSC girder analysis and design as per AS 1500. We are going to use the Queensland TMR sections for our today's sessions. As these sections are recently introduced in the software, we thought it would be better to just go through these sections in our training. And I believe everyone has installed MIDAS Civil NX and are ready to begin with the session. If in case anyone is still installing, there will be 5 minutes presentation in few slides. I'll just explain what we are going to model today. In the meantime, you can try to install Civil NX if you haven't yet. And if you are facing any issue, please type it in the chat box. Eric will be replying to your messages to resolve the issues. Okay. And also, yeah, one thing I would like to let you know, if there are any questions between the sessions, please keep on addressing or questioning in the chat box. You can write those questions in the chat box. If those are simple ones, I'll reply right away. If more detailed explanation is required, please wait until after 2 p.m. Sydney time. So we can have more time for discussion and we can go back and forth in resolving your issue. We have also provided a step-by-step tutorial. Eric has shared a Dropbox link in the chat box. So this tutorial, we are following the same tutorial, but I recommend you to keep that tutorial for practice later on, and you can just follow the steps which I'll be highlighting in the screen. There might be slight differences between my steps and the tutorial, but it will be efficient to just follow my steps and use tutorial later on for practice. And there was one question on the chat room that the Dropbox link could not be accessed. So maybe in the meantime, Eric will transfer the contents in a Google Drive and share the Google Drive link in the chat box. Maybe you can access the Google Drive link to download the materials. Also, along with the tutorial which we are sharing, there are other tutorials for other kinds of structure already provided in the installation directory, installation location where MIDAS Civil is installed. We can see the installation path on the screen. For any other structure, you can check out the tutorials and the models of those tutorials in the C drive where the software is installed. So let's begin. This is our objective for today's session. First, we'll understand the design process. Then we are going to use the pre-stressed wizard to get our geometry ready. And then we'll modify certain things after model is generated. Then we'll analyze and extract the results. And finally, we'll design as per AS1500. Since we have 2 days for this training session, even if we are behind schedule for today's session because today is pretty tight, we will continue the design part tomorrow and then the API executions with Civil and using the same model. So let's try to cover everything today, but if we are short of time, we can do some things tomorrow as well. So make sure you attend tomorrow's session as well. Okay. So whenever we have any design, all the engineers must be aware of this process. We first assume some preliminary data, material data, section data. We have a geometry. This is a MIDAS suggested workflow. Assume some parameters, use the wizard, feed in the values to get our basic model ready, modify that model as per our project requirements, and finally conduct design check using MIDAS. In the design report, if certain members are failing, then we'll understand what is the parameter by which the members are failing. If you need to add more reinforcement, we'll increase the reinforcement. If you want to change the section size itself, we'll change the section size and then redo the entire process again. So in this same procedure, we are going to conduct our training. Now this is an example of the bridge layout which we are going to model in this training session. So it is a 3-span continuous bridge section, PSC Composite Bridge Sections. There will be 39 at 616, meaning there are 40 girders of TMR sections and total 7 piles below the pile cap. Total width of the structure would be around 25 meters. This is the perspective view of how the model will look like once it is complete. Few loading details which we are going to provide. We are not going to provide some specific loads. We're just providing some common loads for any kind of structure. So self-weight, superimposed dead loads, pre-stressed, and temporary loads such as wet concrete. If there is any special requirement that you would like to see how a particular load should be applied, please let me know in the chat box. If we have sufficient time, I will apply that load in the model, or else I will just explain you how to apply that particular loading into the model via demonstration. These will be our construction stages. We are also going to include construction stages in our session. So in the stage 1, we are going to activate the substructure, self-weight, and the substructure supports. Stage 2, it will be girder and diaphragm activation, pre-stress load activation, and support and links to connect the superstructure to the substructure. Stage 3, we are going to activate wet concrete to simulate cast in situ slab. Stage 3-2, we are going to activate the slab, and once slab is activated, then we have to deactivate the wet concrete. Stage 4 is activating SIDL loads such as median, crash barrier, and so on. And stage 5 is a long-term stage, which will be the lifespan of our structure, 50 years, 100 years, whatever we input. Okay. So this is what we're going to model. So let's begin with the software. Just share my screen. Again, I'll start with the actual data input in about 2 minutes. I'll first explain the software interface for those who are new to the MIDAS Civil. Okay. So As soon as you double click the desktop icon, this is the interface which you will see. You can just go to the left top and new project. So a new MIDAS Civil project will be open. All right. So starting with the left top, just explaining the interface in about 2 minutes, so everyone can be ready with the civil and then we can start the actual modeling process. Okay, starting with the left top. So we have a ribbon menu. By following the ribbon menu, we can model our entire structure. I'll not explain some miscellaneous options. I'll be just focusing on the options which will be frequently used. So in the structures tab, we have various wizards. So wizards are small input boxes where you can quickly feed in the data and get our model generated. Manual modeling is always a way to generate a model, but wizard is something which will increase our efficiency in modeling the same geometry again and again. Node element. So all the basic CAD tools, node creation, element creation, copy, translate, move, divide, merge, all of these are available under node element option. Under properties, everything that is related to properties, material properties, section properties, hinge properties, everything can be defined under properties. Boundary, again, everything representing boundary conditions, linear supports, multilinear supports, fixed elastic links, compression only springs, rigid links connection, force deformation curves can be defined under boundary tab. Under load, so again, everything related to static load, temperature, pre-stress, moving load, dynamic, heat of hydration, settlement is available, can be defined under the loading tab. Analysis provides many types of analysis controls, such as for P delta consideration, buckling analysis, eigenvalue analysis, moving load, settlement, construction stages, nonlinear analysis, and etc. Result will provide all the options related to observed results, bending moment, shear force, deflections, strain, and so on. Load combinations as well is provided under the results tab. Dedicated tab for pusher analysis is provided. Dedicated tab for design, again, will be conducting design for our session. So we'll understand about these options in the actual session. If you need to conduct rating with respect to a particular code, a dedicated rating tab is provided. And finally, apps, which we will be using tomorrow for our API executions. To the left hand side, we have a tree menu. Everything which we will create, assign, modify will be highlighted in the tree menu. To the bottom, we have a command window. If the software needs to provide any warning or error, if you are mis-entering a particular data in a dialog box, it will be highlighted in the command box. To the right bottom, we have unit systems. So currently those are set to kilonewton meter. So at any point during our modeling, if we need to enter our weight or length unit systems in different parameter, different units, we can change those to, let's say, ton, and then our input for the loadings will be in ton meter, ton per meter, or the type. It will depend on the type of load which you are entering. All right. Okay. Now cube boxes. So just below the ribbon menu and above the tree menu, we have few icons. So these are shortcut options for all the options which are already included in the ribbon menu. These shortcut icons will help you in increasing the efficiency while modeling. So this single option will be frequently used. So you can see the fourth option from the left hand side will be frequently used. Then you can just hover over those options and you can identify what does that option represent. Then activate all and active only or inactive options. Again, these are frequently used options. Then there is a cubic option. If you hover over it, says hidden, it will help you to toggle between the 3D view, rendered view, and the line element view, node element view of the geometry. Okay. In the center, we have a modeling window. And in this modeling window, we have a node dialog box. If you select any node, it will be highlighted in the node dialog box. If you select any element, just to the right of the node dialog box, we have an element dialog box. Like analysis, pre-processing and post-processing outputs. To the right top in the modeling window, we have a navigation toolbar, which will help you navigate between elevation view, top view, plan view, sectional view, and so on. All right. So this completes our explanation with respect to the software interface. Now let's begin with the actual definitions and to generate our, and let's begin with the session. So first we will save the particular file. So that software obviously has an autosave feature for every 10 minutes. But if we did not save it at the very first instance, it will be all included in the temporary storage of the laptop or system. And we can the data will be lost if there is some net connection issue or so, because MIDAS Civil requires internet connection when we are modeling our geometry. Okay, so again, left top and click on save. You can save it in any folder on your local drive. So make sure, if possible, try to save your file in any local drive of your system. You can give it as PSC girder. Save. Okay. Now once we save it, we'll make sure that everyone is in the same page. So by default units are in kilonewton and meter, but if in case you have a different unit systems on your screen, please change those to kilonewton and meter from the right bottom part of the window. Okay. Since we are going to use the wizard, we will first define some sectional properties, so we can directly select those from the drop-down menu in the wizard. So let's go to properties and material properties. We are going to define 3 material properties in our model. One is C50 grade of concrete for superstructure. Superstructure as in, to be specific, the girder of the composite section. C40 grade for the slab of the composite section and also the substructure, and a steel material for the tendon. So properties, material properties, click on add. From the type of design, select concrete. Standard, select AS17. AS17 represents Australian standard AS 5100-2017. We have provided a short form of it called as AS17 RC. And from DB, select C50. Once we select C50, we can see under the concrete section, the material properties are calculated following the Australian standard. In case you have different material properties, if you want to modify your material properties in terms of density or any other parameter, there is also an option to user define the material property. So we can use that option to manually enter all of these inputs. So always make sure you check the calculated material properties. If we are satisfied with those, we can proceed, or else manually edit those properties. Once this is defined, click on apply. There might be issue in some of your screens that you could not view the OK and apply button. So besides concrete, there is this negative symbol, minimize symbol. So you just minimize the dialog box, so you will be able to view the OK and the apply option. And even after minimizing the concrete option, if you cannot view the OK and apply option, then I would recommend you to change your system scale to 100%. So you can just go on desktop, right click display options, and there is a scaling option. You can change the scaling to 100%. All right. Now, once we have selected concrete C50, click on apply. Similarly, C40. So just change C50 to C40 and again click on apply. So we have defined two materials, C50 and C40. For those who are new to the software, again, a small difference between OK and apply. If I click apply, the material is added, but the dialog box remains in the same place. But if I click on OK, the material will be added and the dialog box will be collapsed. Then you again need to click on add. Okay. Now third material is steel. So please select steel from the drop down. Select ASNZS 4672.1 and 1670. Again, same is applicable for steel as well. You have to always check the properties which are calculated by following the respective standard. If you agree with those properties, you can continue, or else you can manually edit these properties as well. Okay, so two concrete materials are added, and finally the third material is steel material. We'll click on OK. This completes our definition for this completes our definition for material properties. Now close. Now let's define time dependent properties. For those who are following the tutorial, this step is being defined at a later stage. But as I mentioned, you can use the tutorial for practicing after the session. In today's session, since you can follow me and do the modeling along with me. So we'll define time dependent property. So besides material properties, time dependent property is creep shrinkage. Click on add. Give name as C50. Again, you can provide any name. This is the naming which I would like to provide. So C50 from the code AS 1500.5 amendment 2. In the release webinar, we had mentioned that we have incorporated the latest amendment of AS 1500, which is amendment 2, which was released in May in 2024. So for all the new projects, I believe you will be using the same code. And since we are using the latest version of the software, we'll use the latest implementation of implemented code into the software. For those who are using 2024 version of Civil NX, you might just use the previous AS 1500-2017 code. Now compressive strength 50,000. Since the units are in kilonewton per meter square, 50,000 will be the input. And exposure environment, I'm going to keep this default. Again, you have to check with your project considerations, and you can provide the respective exposure environment. Hypothetical thickness, I'm going to enter 1 meter for now. This is just a temporary value which is used to manually verify the creep coefficient and the shrinkage strain parameters over here. Because it is a composite section which we are defining, it has different hypothetical thickness for pre-composite and post-composite sections. Therefore, software will auto-calculate those at a later stage. Please park this point. I will call back this option when we are defining the separate composite sections hypothetical thickness at a later stage. So just enter 1 meter. Any number is fine over here. I'm considering 1 meter and click on apply. Similarly, define time dependent property for C40. So it would be 40,000. You can just look at the results and click on OK. Now we have defined two time dependent materials. Close this. With respect to creep and shrinkage. Now we have to define compressive strength. So in the same time dependent option, drop down menu compressive strength, click on add. C50 again for both the materials, both the concrete materials, AS 1500.7. We can see there is no amendment because there is no change in the updated code in terms of compressive strength. So we'll enter 50,000. Redraw graph and OK. Similarly, perform the same step for C40. AS 1500.5-2017 40,000. Redraw graph and click on OK. Close the time dependent box. Now in the tree menu, so you can go to the works tab in left hand side tree menu. We can see three materials are defined, 2 creep and shrinkage time dependent materials and 2 compressive strength time dependent materials. In MIDAS Civil, if we have defined any parameter but not used it anywhere in the modeling, it would be shown in blue color. So we can see all of these are in blue color because we have not assigned these to anything. With respect to materials, we have to assign this, with respect to time dependent materials, we have to associate it with particular material. So wherever the material is assigned to any element, these time dependent properties will be indirectly assigned to that particular element. So using the material link, we'll assign that. So in the same ribbon menu, properties, material link, select creep shrinkage C50, compressive strength C50. Take C50 to the next in the right hand side column and click on add. Perform the same action for C40 as well. From the drop down menu in the top, select C40 in the both rows. Take C40 to the right hand side and click on add. So we have linked both the time dependent material properties to the respective materials. Close. Now we can see in the tree menu, these have turned black. It means they are associated with something in the model. Next up, we'll be defining section properties, but I'll wait for 30 seconds for everyone to arrive at the same step. And until then, I'll go through the chat and see if there are any questions. File license, protection key, emails, training. All right, so good. There are no questions until now. Okay. I hope everyone has finished defining the materials. Now we will define the sections. So in the same ribbon menu under properties, we click on section. So again, we'll be defining a couple of sections. So let's start with the first one. So click on add. We are first define a section for pier column. So DB user from the drop down, select solid round. We are assuming our pier is round. You can give it as pier column. We are going to use a user defined section. So user and enter 1.2. So 1.2 meter will be the thickness of our pier column. Click on apply. Second, we are going to define a pier cap. So under solid round, select solid rectangle. You can name it as pier cap. Select user. H will be 1.2, B will be 2.1. So height of the pier cap 1.2 meters, width will be 2.1 meter. Change the offset to center top. So this offset represents the load, the location on this section where the load will be applied. So if we change to center top and click display offset point, we can see this red dot represents the reference line for load application for this section. Because in a pier cap, the loads will be applied at the top. They would travel through the section until the centroid of the section, and then it would resist the load. So we can use center top modeling, or else if we are fine with this ideology that the load is applied at the top, it will transfer to the center and then it would resist, then we can do center top. If not, even conventionally engineers are using center modeling, even that is okay. But for today's session, to be as accurate as possible, I am using the center top offset. Center top and click on OK and apply. So we have added two sections, pier column and pier cap. Okay. Now we will define a third section, cross beam. So it would be solid rectangle. Okay. Solid rectangle. I'll name it as cross beam. Cross beam you can also consider the diaphragm section. In user, height I'm considering 1 meter and width will be 0.6 meters. There will be a slightly higher offset for cross beam because I'm assuming my cross beam will start below the slab level. So in a composite section, it is a girder and there is slab. So usually the cross beam is provided perpendicular to the girder. So it means we have to provide an offset for the slab. So select center top. Click on vertical offset user and minus 0.23. On extreme fiber, click on display offset point. We can see this red dot is some distance above the center top because we are assuming that there would be a slab. If we have provided center top, then at the intersection of diaphragm and slab, it would be the stiffness would be considered double. Hence, in order to avoid that, and the material would be considered double. Hence, in order to avoid that, I'm using minus 0.23 center top offset. And click on OK and apply. So we have provided three sections, defined three sections right now: pier column, pier cap, and cross beam. Now we will define our section for our PSC girder. Okay. Now fourth section, go to PSC. From the drop down PSC value, and under section data, DB. This is a recently added database section. So under code, select AS, and in the type, select AS PSC deck unit TMR. And select the last section, just 24-25 meter deck unit. Click OK. You can view the cross-sectional properties from this defined by coordinates or the coordinates of this particular section. You can also modify this section if you have a different user defined section. Parameters for design. We can enter just one input in each of these parameters, because these parameters will not be used in the analysis as well as design, because these parameters are strictly restricted to some database sections for Russia. So we have selected Australia and then we have selected a particular type. Instead, if we had selected some Russian sections, then these parameters would be defined accurately. For our session, or with respect to Australia or any other code apart from Russia, these design parameters will not be used. Hence, just a nominal number should be added so that we can proceed with the definition. And where auto is available, just click on auto. So in the parameters for design, just click 1 meter, thickness for torsion 1 meter, and beneath it, select all the auto options and click on apply. So this is just a girder section. We are yet to define a composite section. So after defining this, we'll go to composite, select composite PSC, name it as composite. PC was the effective thickness of slab. So this would be 0.616. Because TMR sections are very closely spaced, we are going to enter very small effective slab thickness, slab width, and thickness as well. So thickness would be 0.23 meters. H is usually provided in terms of steel composite bridges. It is the sacrificial haunch in when we are pouring in deck slab concrete. So right now it will be 0. Click on import. We can observe the same name which we have imported for the girder from the database and click on OK. And in this black box, black window, we can see the section which we have defined. Now, since this is a composite section, it has different material properties for slab and girder. We need to again create those materials so that the modular ratio will be calculated appropriately. So click on select for DB from DB, concrete material for slab, again AS17, C40, and for girder, again AS17 and C50. The same materials which we have defined previously. Once you enter these parameters, you can see the some data has been filled. So EGD by ESB is the elastic modulus for girder versus elastic modulus for slab. Density of girder versus density of slab. Poisson's ratio of girder, Poisson's ratio of slab, and thermal coefficient ratio of girder versus slab. And click on OK. We have to change the offset in this section as well, because even in this section, load is applied at the top of slab. It will be carried away to the centroid and then the section would register the load. So center top and OK. This completes our last section definition. So just click on OK to complete the section definition. So in all, we have defined 5 sections. Again, I will wait for 30 seconds for everyone to finish this definition. Until then, I'll go through the chat to see if there are any questions on what we have done until now. Training session. Channel. Check the Q&A box. All right, no question. I hope then everyone is able to follow what we are defining in the for the sections and material definitions in the software. Okay. I think everyone has completed defining the sections. Close this dialog box. Okay. Now, once these definitions are complete, we can start with the wizard inputs. So we'll go to structure and pre-stress composite bridge. Again, for those who are using just a laptop screen, please make sure you can view the OK, cancel and the options at the very end of the tab. Because if you're not able to view those, then after filling in all the details of the wizard, you would not be able to execute the wizard. So make sure you can see the open, save as, OK and cancel option at the extreme end of the wizard. If not, I would recommend you to change the resolution of your screen or just connect your system to a big monitor. Okay. So again, to repeat how we have accessed the wizard, structure and PSC or pre-stress composite bridge. All right. Now we will one by one fill in the details in the wizard. Also, a small note, do not press OK to switch the tabs because this is frequently encountered mistake that once the definition is complete, if we are in a hurry, we just press OK and the wizard will be executed. Make sure you only press OK once you have completed all the definitions in the tab. You can switch tab from over here. Okay. So I'll let you know when we should execute the wizard and press OK. Until then, we can just switch the tabs from the top buttons, top options, the options. Okay. There is a question. How can I have the shortcuts same as MIDAS Civil? Do I need to be adding them one by one? I guess Abdul, you are using the 24 NX Civil 2024 NX. So yeah, the options in 24 NX are a bit different. I would recommend you to download 2025 version. In that we have make sure that the options in Civil NX are at the same position as in Civil. So as you can see in my screen, these options are the same as MIDAS Civil, but in 2024, the options are at a different location. We thought that would be more convenient. We had tested it on 24, but as per the client's feedback, they have already used to Civil. So in 25 release, we have replaced the option in the same position as MIDAS Civil. So I recommend to download the 25 version and it will be in the same position. Okay. Now let's begin with the wizard inputs. So we are in the first layout tab. Again, modeling type all frame. Other couple of options are provided. You can explore those later. In today's session, we are using the typical conventional all frame option. Span information 24, 25, 24. It means first span 24, second 25, and again 24. Deck width 24.64. Layout offset, again, park this point. I'll refer to this point at a later stage. Just give it as 0 for now. Keep it as 0. Spacing A, we can refer to the diagram to the right and we can provide the spacing A. Basically, it is the gap between the two girders, two face of the girders. Spacing B is usually the distance of bearing center from the face of the girder. So as per your project requirement, as per the drawing, you can give these spacings. All the values which I'm assuming in today's session are my own values. These are not representing any particular project. So I would recommend please double check these values for your own project and do not follow the same values even for your existing projects. And if you need any explanation in regards to any particular option, please let me know. Okay, continuous girder, it means it will behave as a continuous action. Now boundary/structure. Again, various options for radius, multi-curve, skew are also provided. But right now we are just sticking to a simple straight 3-span continuous structure. So boundary structure, we are going with substructure modeling. In these guide options provided, we can have a look at all the references. A reference diagram will pop up. You can refer to this guide and enter various parameters. I'm already familiar with these parameters, hence I'll be directly entering these values. So with substructure, elastic links at all the locations, Kx is vertical. So 1e6, it represents 10⁶. In vertical direction, our stiffness is infinite. So 1e6. In horizontal direction, 3000. Transverse direction, and in longitudinal direction, again 3000. Same is provided for the pier as well. So in pier, Kx 1e6, Ky 3000, and Kz 3000. Elastic link length, this is to represent the bearing height. Elastomeric bearing height. And we are assuming elastomeric bearing. Again, these values are of my own. For actual values, you have to first assume a particular bearing size, number of layers, number of steel pads, rubber pads, their thicknesses, and refer to the Australian standard wherein these stiffnesses for each specific size of the bearings are provided. Pier, so pier material, as we have previously assumed, pier material would be C40. All the substructure material would be C40. For pier cap, select pier cap section. Length of the pier cap would be 24.5 meters. To the right hand side column, from the drop down select pier column. Height of the column I'm assuming 15 meters and spacing 6 at 35. So these columns will be equally spaced below the superstructure at 3.5 meter distance. So either you can enter @ symbol, or else we can enter 3.5, 3.5, 3.5 6 times. And at the bottom of the pier, I'm assuming fixed. In tomorrow's session, we will be using the API to auto-generate the pile cap and the piles beneath our structure. Again, as I mentioned, manual modeling is always possible, but API is something, or automation is something which will help our increase our efficiency and generate the model quickly. So we have completed the definition in the layout tab. I'll wait for 30 seconds so that everyone can complete this definition, and I'll quickly go through the chat to see if there are any questions. Okay. I think everyone has completed the definition in the layout tab. Now let's move on to the second tab, which is the section. Some definitions are pretty self-explanatory, so I'm not going to explain those, such as deck thickness. So it is 0.23 meters. Deck material. So C50 is the deck material. sorry, deck is slabs over here. So it is C40, girder is C50, and diaphragm is C40 again. So C40, C50, C40. Then we'll first cover the left hand side, then we'll move to the right hand side of this same tab. So diaphragm, so divisions per span. Again, there are multiple options, distances. You can specify the distance if you want an intermediate diaphragm in your structure. I'm using divisions per span in this case. It means if there is a single span, in how many divisions you want to divide that span. Let's say it is a single span. I say divisions per span is 2. It means it will create a single intermediate diaphragm at the center so that we have two different sections, one to the left, one to the right in a single span. So it is divisions per span. If I enter 1, it means the diaphragm would be created just at the support locations and not at the intermediate locations. So I don't want any intermediate diaphragms, hence divisions per span is 1. And also the name. So from the drop down, we have to select the diaphragm which we have defined. So it is, we have named it as cross beam. So from the drop down, select cross beam. Okay. Now girder information, since we have entered 3 spans 24, 25, 24, we can see 3 tabs for girder information is available. Now span 1, from the drop down, select composite. Similarly, go to span 2, from the drop down, select composite, and span 3, select composite. Since this wizard is for composite sections, you can see only the composite sections which are defined in the model are available, which is the section 5. All other 4 sections are non-composite sections, general sections, hence those are not even visible in this wizard. So make sure you have a composite section defined so that you can readily select that section. Okay. Now in the number of girders, as I explained in the presentation, there would be 40 girders in our model. So what we need to do is, here there is 6, enter 40, and besides to it, it is an apply option, click on apply. So we can see now there are 40 rows we need to enter some values. If we click on guide, we can see how this girder offset should be provided. So this girder offset is by referring the layout offset reference, and layout offset is a reference from the center of the carriageway width, deck width. But as I mentioned, the layout offset which you have provided in the layout tab is 0. It means my layout offset reference line is at the CG of the deck slab, carriageway width. Therefore, all the references which we need to provide is referring to the center of the carriageway width. So let's do one calculation. Our total deck width is 24.64. So if I consider 24.64 at deck width, and if I consider the 0.67, or else I'll just open paint and I'll try to explain it. Let's say this is my deck width of 24.64, and this is the center of the deck width. This is our reference offset line. We need to provide offset for the reference locations. This will be the first. This will be second. let's try it manually. Second and third and so on. So basically this will be 24.64 divided by 2. This distance, this half, and since our effective slab width is 0.616, so we need to divide. We need to subtract 24.64 by 2 minus 0.616 divided by 2. And we will need an Excel sheet for this calculation because there are 40 values which we need to enter. Okay, so deck width, I'll quickly fill this up. 24.64. Each slab width 0.616. And first slab. So first slab reference from center would be 24.616 divided by 2 minus 0.616 divided by 2. So it will be 12.012. So okay. So this is, and it will be minus because we can see left is minus and right is plus. So the first is minus 12.012. In the same fashion, now the second distance would be 12.012 minus 0.616. So this would be 12.012. Okay, since this is negative, let's multiply this by minus 1. Minus 1 is equal to into. Okay. Now further, I'll just take this to the right. 1, 2. We need to create 40 rows. And so this is our very first value. So you will use this value as a reference and plus 0.616. So we are subtracting in a sense 0.616 from the very first number, or you can say add because it is negative. So I think you will get it, and just fix this value because this is the constant number which we are going to subtract, and just drag it until the very end. So if we do this properly, we can see the first and the last value is the same. I think everyone, you have to do this because we are going to copy paste this entire table into the civil. Or else you have to manually for each row type in the exact values. So for simplicity, you can enter the first number as minus 12.012 and add 0.616 to the previous number and just drag the entire column so that the difference between two consecutive values is 0.616. And then you just copy this, go to civil and paste all the values. So you can see first is minus 12.012 and last is also 12.012. Okay, there is a question. First slab reference from center, how did you get that? If we look at this image, my total deck width is 24.64. So if I look at the distance of the extreme end from the center, it is 24.64 divided by 2. So 24.64 is okay from this position center till the extreme end over here, and my slab is over here. This small slab. The first one is very big, and my effective slab width is like this. So this is the girder at the bottom. These are my effective slab widths. And this green portion is 0.616 slab width. Therefore, 24.64 divided by 2 minus 0.616 divided by 2 will arrive at this center of the slab. Okay. So I'll wait for 30 seconds for everyone to complete this step. Open Excel. We have our deck width. Each slab width is 0.616. So deck width by 2 minus each slab width by 2 will provide me the distance from the center to the center of the extreme slab. So 12.012. Since it is negative, I have multiplied it by -1 and just added 0.616 for every row, which will give me centers of every girder throughout the carriageway width. To confirm, just check your first input and the last input. They must be the same, which is 12.012. For those who might take some time, I'll just copy this table and paste it in the chat room. So you need not spend time in recreating this. And paste. Then just take the second column of this table and paste it in the civil in the first girder. Okay. Now transverse deck spacing, it is 1 meter. I'm assuming it to be 1 meter. Okay. Transverse deck spacing 1 meter and check off this generate 10 points elements. It is not required. Basically, it just generates additional nodes at every 10th position of the element. ASTO code recommends us to perform checks at every 10th location, but no such thing is mentioned in Australian standard. Therefore, we don't need extra nodes at every 10th point of the 10th position of the element. So just check off this generate 10 points elements. Okay. I'll wait for 10 seconds so that everyone can complete this section inputs, then move on to the tendon inputs. Okay. I'll go to tendon inputs. So before defining tendons, we need to define a tendon property. What kind of strands, what is the material for the strand. Therefore, there are 3 dots besides tendon property. Please press those. We could have defined this tendon property outside the wizard as well, but I purposefully left it for the wizard so that if you miss to define anything before you start with the wizard inputs, we should know how we can input it even during the wizard definitions. So besides tendon property, press those 3 dots. Tendon property dialog box will pop up and click on add. Give name as tendon. Tendon type would be internal pretension. From the drop-down, select 1670 material. For the tendon area, again, 3 dots besides tendon area. Strand diameter is 15.2, 1 cross 7, number of strands as 1, and you can click OK. The tendon area and the strand diameter is automatically calculated. Relaxation coefficient, again, we'll select Australian standard is 1500.5 2017 and coefficient 5%. Again, this is an approximation assumption. Please follow appropriate codal guidelines, check with your contractor and provide the appropriate relaxation coefficient over here. If you have varying relaxation coefficient as in short term and long term, then there is always an option to user define the relaxation coefficient. You can vary the coefficient with respect to time. Now click on OK and close. So we have defined the tendon property. Now we will auto generate the tendons. Since this is the standard sections, there are fixed location of tendons. So besides this image to the left, we have the auto generation option. Click on the auto generation. Since we have defined the section through a database, it has automatically picked up what kind of section it is. It is Australian section, PSC unit TMR deck units, 24-25 meters deck units. We can confirm if these definitions are correct and click on OK. So the standard tendon locations for these units are generated. All right. We can provide a particular jacking stress over here. I'm not going to modify any jacking stress. I'm using the default values. Just click on add. We also can provide debonding lengths to particular tendons if we check on this detailed option. But again, we are going to cover the debonding lengths through the API in tomorrow's session. Therefore, I'm not going to provide any debonding lengths today in our model. So once we click on add, we can see span 1, 22 tendons. So these tendons are just created for span 1. Now we need to also assign these tendons to span 2 and span 3. So under the segments at the very top, select span 2, click on add and select span 3 and click on add. So in the tendon assignment list beneath, we can see span 1, 22 tendons, span 2, 22 and span 3, 22. I'll wait for 10 seconds, 10 to 15 seconds for everyone to complete this definition, and then I'll proceed. If there are any questions, please let me know. All right. I think everyone has completed the standard definition. Now we'll move on to the load definitions. Okay. So as it is self-explanatory, we can follow this notations and enter our respective widths. So B1, it's crash barrier. I'm assuming in 0.5. B2, just enter 11.52 for now. I'll explain in some time why we have entered the specific value. B3 0.6, which is the median unit. B4 11.52 and B5 again 0.5. So this addition B1, B2, B3, B4 and B5 should be equal to the deck width which you have provided in the layout tab, which is 24.64. So if we add everything, our value would be 24.64. If this is not matching the deck width units in the first tab, then Wizard will not execute the command and we would have an error while executing this wizard that the deck width units are not matching. Therefore, always check these addition is equal to the deck width number which you have provided in the layout tab. Okay. Now, dead loads. So equally to all girders means whatever loads which you are going to provide will be applied equally to all the girders. But this is not applicable for crash barrier or median unit provided at the center, because the loads at that location, even their self-weight, should be distributed onto the girder which is closest to that particular loading area. So DC before composite corresponds to this very first box over here. DC after composite the second box over here, and DW after composite corresponds to the box just below it. So before composite, yes, everything should be applied equally to the girder. Therefore, we have checked on self-weight and wet concrete. After composite, barrier and median strip, no, these should not be applied to equally to all girder. They should be applied at their respective locations. Third, DW after composite, yes, self-weight or not self-weight, wearing surface should be applied equally to the all girders. Therefore, we'll check on first and the third option. Self-weight is checked on. Wet concrete density, I am assuming wet concrete shade higher density, so 25 kilonewton per meter cube. Thickness should be the same as the deck unit, so 0.23. Crash barrier 9. Median should be 4. Again, you have to calculate these loads appropriately. These are just assumptions which I'm considering over here. These are not actual values. Bearing surface weight density would be 22 and thickness, let us do 0.1. Okay. Now this completes our definition. I'll wait for 10 seconds so that we can move with the definition of moving loads. Okay. So click on define moving loads, select Australia moving load, click on OK. Again, in recent revision or recent update release of 2025, we have added B-double vehicle as a standardized vehicle. So in today's session, we are going to apply B-double vehicle in our model. For those who are using any other version except 2025, you can choose any other vehicle, because in those versions B-double vehicle would not be present. So define moving load, select Australia, click OK. Once we press OK, this live load option will be activated, and once we press on live load, the other corresponding tabs would be active. So click on define traffic lanes. We are going to define 2 traffic lanes just at an approximate location. First is, okay, so enter 2, so 2 dialog boxes are present, and 10.57 and 14.07. I have tried to keep these distances as close as close to the center as possible. But again, you can choose your own traffic positions and provide these distances over here. So you can see this distance is provided from the extreme left hand side of the carriageway width. So 10.5 somewhere over here and 14.7 somewhere to the other side, because at 12 we have, let's assume our deck width is 24.6, so 12.3 we have our median, and therefore I have assumed the vehicle at immediately to the left and immediately to the right. So 10.57 and 14.07, press OK, and under define vehicle, besides that click define vehicle, select add standard, select rating vehicles, and from the rating vehicle, okay, there are a couple of vehicles added over here. So from the rating vehicle, we will select Queensland 50.5 B double vehicles. Don't worry if these additional vehicles, group 1 and group 2 vehicles, are not added in your version, because since I am testing one of the vehicles which we are about to add, I have these vehicles in my screen, but in your screen it would be just until Queensland QLD 68 ton 7H. It is completely fine. So we are going to select the first Queensland B double vehicle, which is QLD 50.5 8G1 GML 19 meters B double. So we are trying to incorporate Western Australia vehicles, hence we have these added definitions, but for now you can select Queensland 50 10.5 and click on OK. You can select any B double vehicle, it does not matter, because yeah, just make sure whatever B double vehicle you select, if it is similar which I'm selecting, our results would match. If not, you would have some different results. And close. I'll wait for 10 seconds so everyone can complete this definition. Okay. Now let's move on to the next step, which is construction stage. Again, we'll be going through the construction stages in detail once the model is generated. Hence, we are not going to spend time in this part. Just make sure you have this option checked on, which is construction stage. And then we are complete with the definition of the wizard. We will also save this inputs. So again, as I mentioned, if we have a new project with some similar inputs, we can just open this saved wizard so that we have all the inputs ready. We will just change few inputs which are modified and we can generate our model quickly. We need not spend time in re-entering all these inputs again and again. So click on save as and give PSC wizard any particular name and save. You can just click on open and confirm if the wizard file is saved. The extension is .wzd. So this is the extension for MIDAS wizard files. So once you save it, then you can click on OK. It will take some time. I'm assuming a couple of minutes to generate the model, because this is a fairly large model. It is 40 girders in a single span. We have 3 spans, so 120 girders, and in each girder there are 22 tendons. So 120 multiplied by 22. So that many tendons are to be generated from the software. So it will take few minutes to generate the model. In the meantime, if you have any questions, please let me know in the chat room. I'll be happy to address those. Don't keep your questions for the last. Since we have time right now, we can address those immediately. All right. Model is generated in my screen. Again, I'll still wait for another minute so that it could also be generated in your systems. If you would like to change the tendon locations, can you do it via the wizard inputs? Yes. So we can. So once we auto generate the tendons, I will just show you how to change those. Okay, so we can use this guide. These are straight tendons, so it does not make a difference. So we can use this guide and just refer to these notations, and we can change the tendon locations, number of tendons and everything. If you want to change it using the wizard, or if you want to change it while you're generating the model. Once the model is generated, you cannot use the wizard to change the tendon locations. You have to do it via a different method. For example, once the model is generated, there are two options to proceed. If you want to change the tendon, you click on undo so that it will your last step would be erased. So that it means the wizard generation step would be erased. Or else we go to the tendon inputs. So we can see there are 2640 tendons. Click on the tendons which you want to modify, and you can change the coordinates of the tendon over here. There are very less chances that you would need to change the location of the tendons because these are precast units. They have standardized tendon locations. But yes, these are the possible ways of how you can change the tendons. For post-tensioning tendons, there are high chances that tendon coordinate needs to be changed. But for precast units, since for these straight tendons, there are very less chances. But I have explained you how to change the units. If required, you can change the units accordingly. All right. Until the time the model is generated at your end, I'll quickly explain what all the wizard has done for us, what all definitions have wizard generated. By that time, your model will be also created. Okay. So again, focusing on the tree menu because everything that is defined in the model can be observed in the tree menu. So 4,000, around 4,600 nodes, 7,300 elements are generated. Materials. So 4 materials, we have defined 3. Fourth one, dummy material for transverse slab are created by the wizard. We can click on any definition and the element to which it is associated with will be highlighted in the tree menu. Time dependent materials, nothing, no change because yeah, we had completed this. Sections. So we had defined 5 sections. 6th section for the continuous slab location is created. So very small, minute, thin section is created. Then extreme end girders, just dummy 1 mm by 1 mm girders to provide enclosure closing to the grillage element is created. And the transverse deck slab unit at 1 meter location are created. Construction stage, will talk about construction stage later. Boundaries, if you look at the boundaries, all the supports are observed. Oh, elastic link, all the elastic links, as I mentioned, vertical will be x-axis. We have provided high stiffness, y would be transverse and z would be longitudinal. We can see the same orientation as we have entered the values for. Rigid links, So these links are used to connect the top of the structure to the bottom of the bearing, to the top of the bearing for force transfer at all the locations, and also from the bearing location to the pier cap location. Self-weight is created. Wet concrete load, as I mentioned, is assigned equally to all the girders. So UDL for the girders is created. Crash barrier loads, these should not be assigned to equal to all girders. Therefore, we can see these are just assigned at the extreme ends since the option was unchecked. Median strip just at the center part. Bearing surface, again, these should be applied equally to all the girders, and yes, they are. Perfect. Pre-stress, again, don't want to display these because it would generate a huge amount of data and it would again slow down a bit for buffering to display those. So yeah, we can just observe that number of tendons and number of pre-stress are the same. Okay. Now after this, we were at the moving loads. So moving loads, again, in MIDAS, there are 3 steps in where moving load should be assigned. First is define the lane, which we already have defined 2 lanes. Second step, we should define a vehicle. The vehicles are also defined. And the third step is to combine the lanes and the vehicles. This third step is not included in the wizard because it is, as I mentioned, it is respect to particular code. Some codes provide restrictions to combine different vehicles and different lanes. Therefore, which are all the non-codal inputs can be entered in the wizard, which are respect to any code. We have to modify it later on. So now we will complete the third step in moving load definitions. So we can see the traffic lanes which are created. We can see the vehicle. As I mentioned, whatever is in blue color is defined but not yet associated with any element or any definition. So we will now define the last and final step of moving loads. So load, go to loads in the ribbon menu, moving load and moving load cases. So load, moving load cases. Make sure you have Australia over here. It would be by default since we have selected that while generating the wizard, and click on add. Okay. Select B double. Provide load case name as MV. Again, as I mentioned, since we are testing out few vehicles of standard incorporation Western Australia vehicles, these options might not be available in your version of the software, but don't worry, we are not going to use that. We are going to use the B double vehicle. So select B double. These are the standard lane factors for accompanying loads. Again, we are not providing any accompanying M1600 S1600 load. So these would not be, it should be none over here. If you want, you can add an additional vehicle and then include those. For today's session, we are restricting only a single B double vehicle entire carriageway. So minimum number of loaded lanes, maximum number of loaded lanes for M1600. Okay, it is invalid because we have not defined anything. B double lane. Again, if I'm as in the Australian code, it has stated that no 2 B double vehicles can be placed in adjacent lanes. So we will just select lane 1 under the B double lanes. We would not select both of these lanes. I mean, we could place them over here, but Australian code restricts us in loading our bridge with 2 B double vehicles. It clearly states that for a single substructure, even though the carriageway is divided, a single B double vehicle should be positioned on the bridge at any point in time. So lane 1 and okay. So under selected lanes, I have selected both the lanes, but under B double lane, I have just placed one lane. I'll wait for 10 seconds so everyone can finish this input. Okay, now press OK and close this dialog box as well. Now we can see in the tree menu, the moving loads definitions are now turned black. It means it is now associated with the model. Okay, now after the moving load definition, we are going to check out the construction stages. So now we'll take a look at the construction stages. I'll just undisplay this. Sorry, undisplay. So we'll first turn on the 3D view, hidden view, so that you can see the bridge. From this base, select stage 1. We can see our substructure activated. Stage 2, our girder and diaphragm is activated. You may recall the presentation slides at the start of the session, wherein I was explaining all the construction stages. So sulfate and pre-stress is active. So in the tree menu, only those options would be visible, would have some data entry beneath it, which are used in that particular construction stage. So all the boundary conditions, all the loads, only if they are present in particular construction stage, it would be highlighted. So for example, wet concrete is not present, barrier, median strip are not present in this stage 2 construction stage. And let's move on to stage 3. We can see wet concrete is available in this stage. Stage 3-2, wet concrete is disabled and the slab is activated. Stage 4, the SIDL loads are activated, and stage 5, there is no change. It's just a long-term stage, life period stage of a structure. Now there are some modifications to be done over here. So let's go to base stage, and besides this base dropdown, there is a shortcut for construction stage definition. We'll go over there and click on first stage and modify. Okay, now we are going to change some age over here. So to explain in simple words, this duration highlights the duration for this particular construction activity to be completed on site, and this age represents the maturity of that concrete when they are activated. Maturity of concrete for substructure and maturity of concrete for coping beam when they are activated. Coping is pier cap. Since we have provided C40 material to the substructure, and this C40 material is associated with a time dependent property, it means in this current scenario, the age of concrete, maturity of concrete when these elements are activated is 0. It would have no stiffness to take any load. So there will be huge warnings, huge deformations, very unrealistic values. So we are going to modify the age to 100 days. We are assuming that it has achieved full strength. So again, 100 is just an assumption. We can provide any number by discussing with the contractor on site at which stage we are going to activate this particular pier and concrete. Click on modify. Same for the coping beam as well. Our second option, define an additional material to which there are no time dependent properties associated with it. So whatever age you provided will not make any difference because no time dependent materials are linked with that particular element. So click on apply. and make sure you are in base stage whenever you are going to modify any properties within the model. Within construction stages, within loads, boundary conditions, anything, make sure you are in the base stage or it will continuously keep popping. Please change the stage to base stage for any modification purposes. So we are in base stage, we went to stage 1, we changed this age to 100 and pressed modify so that the substructure and superstructure age is modified. Now we'll go to stage 3-2. Again, provide this age as 10 days. I'm assuming when my section is capable to consider its self-weight, it has 10 days of maturity of concrete. So change the stage to 3-2, enter 10 in age and modify the age of all the 3 sections provided below it. And click on OK and close. So we have made some modifications in the construction stage. We have modified the age of elements for stage 1 and stage 3-2 elements. Okay. Now, if you recall, I explained that software is going to auto update the notional or hypothetical thickness for composite sections. So the input which you have provided is 1 meter, but when our model is generated, software is going to auto update that. So we are going to define a separate construction sequence so that we will be able to tell the software what is the loading age of that element and also auto calculate the notional thickness for that particular age. So to the right of this base stage, we have composite section for construction stage. To the right of base stage, we have composite section for construction stage. Select a particular section and click on modify. So it represents active stage is stage 2 because my girder is activated in stage 2. It has provided stage 2. My slab is activated in stage 3-3. Therefore, it is stage 3-3. Kindly enter appropriate element age over here. So 7 for girder and 10 for slab. So following this age, this H hypothetical thickness would be calculated by the software for this loading age. Click on OK. Click on update all H. This will state recalculation of notional section dimension for one composite section in construction stage has been successfully completed. So if we just look at the H parameters, we can see 0.254 and some other values and 0.167 for the slab is calculated accordingly. Because the notional thickness for pre and post composite sections would be different. It also varies upon the load upon the material. Therefore, we need to auto calculate it and provide a separate definition for composite section for construction stages. Now, close this dialog box. So this completes all our inputs for the model. I'll wait for 10 seconds, 10 to 20 seconds for everyone to complete until this step. And in the meantime, if there are any questions, I'll be happy to address those. If you want me to repeat any step, please let me know. All right. Once all the definition is complete, we can analyze our model. So you can go to analysis and press analyze. Now again, this will take some time. It is a big model in terms of number of elements, number of tendon profiles, and number of loads. Therefore, it will take at least 10 to 15 minutes to analyze. So I have already analyzed a particular model. You can uh, analyze this model in your particular systems so that you can view the results after it is analyzed. And in the meantime, I will just show few results. I'll just demonstrate how the results can be viewed in the model. So let me open a model first, which I have already analyzed. And regarding the design part, I think it is better if we cover the design part in tomorrow's session. So in tomorrow's session, we will cover the design part in first 15 to 20 minutes, and then we will move towards using the API functions. Open. This completed model is also provided in the training materials guide. So once you follow the tutorial and generate your model, in order to compare all the results, this sample model, completed model is provided. So you can compare the models, and if the results are matching, that means you have followed the tutorial. And the model is completely correct. If you find any discrepancies, then there are some parameters which are not matching the tutorial inputs, and those can be referred back, and the discrepancy can be eliminated. Okay. So this is an already analyzed model. As I mentioned, it takes around 10 to 15 minutes to analyze the model. So I'll quickly demonstrate how the results can be viewed. And again, the same steps are provided in the tutorial. So you can follow the tutorial and observe the same results once the analysis is complete. So starting with the reaction values. So we'll go to reaction, reinforce reaction. This is moment. Okay. So before we look at the values, we have generated some load combinations. I'll explain how those load combinations can be generated. So in order to perform the design, the load combination needs to be generated in the respective tab. So concrete design, since this is a complete model, combinations already present, but in your scenario, and combinations can be generated before analysis and post analysis as well. So need not worry if you have clicked analysis and the model is analyzing, you can generate it post analysis as well. So you click on results, load combination, concrete design, auto generation, the auto generation loads by following this auto generation tab. Okay. Now look at the few results. So first of all, reaction. So these are all the combinations which are generated. You can click any of these combinations, click OK. You can even see the reaction tables, reaction values in the tree menu during the construction stages. You can see FZ, turn on the value, check on the legends. Again, every step is described in detail in the tutorial. So you can follow the tutorial and look at the values. Same for stage 2. The values are increased because the superstructure is activated. Stage 3, sulfate is activated. Stage 4, sulfate is stage 3, wet concrete load is activated. Stage 3-2, wet concrete is deactivated and slab is activated. Stage 4, SIDL loads, and stage 5 is the long-term stage. Now we'll look at few deformations. Deformation contour in stage 1, DZ, turn on the values, deform, turn on the legends. There are very less number because our unit systems is in meter. We'll change this to millimeter and observe our deformations. Very less deformations. Stage 2, huge deformations, 31 mm upwards. This is because of the pre-stressing of the girder in this stage. 3-1, these has decreased a bit from 31 to 26 because the wet concrete load is applied. Now in this stage, the composite action is applied and the wet concrete load is deactivated. Stage 4, long-term stage. We can check the loads. So summation includes all the loads acting onto the structure, which is dead load, erection 1, which is self-weight, erection which is SIDL load, erection 2, which is crash barrier load, tendon primary, creep primary, and shrinkage primary. So we can also view these shrinkage primary loads and tendon primary loads individually. Yep. So this is how a structure will behave in creep primary. Similarly, we can observe other deformations, but let's move on to the beam loads. So again, stage 1, bending moment. I'll use the summation option. Turn off the deformation, calculation apply. Stage 2, when the girder is active, you just look at the dead load. You can see pure sagging and the cross beam is acting as a continuous beam. Stage 3, stage 4, again there will be no change because it's just the self weight which will be constant throughout. If you look at summations, then we can find changes over here. We can observe the tendon secondary forces. And change the units to kilonewton meter, so that, yeah, 13 very less minimal tendon secondary forces, I would say. And stage 4 and stage 5 as well, long-term stages. We can also observe the results. We can also observe the results in a tabular format. For example, let's say we are in final stage. If you want to observe the results for construction stages, we need to be in a particular construction stage. And the result visible, beam result, force. You can select any of the load combination, any particular element. In MIDAS, the values are obtained at every 4th location of the element. Therefore, we can see part I, which is the start, 1/4, 2/4, 3/4, and J. Yes, okay. The results at every 4th location will be calculated. To observe the concurrent values, right click, view by max value item, and it will give me the X row and column headings for the concurrent values. I'll not do it right now because, as I mentioned, model is pretty big. It will take some time to generate. You can also observe the vehicle placement for any particular load, for any particular element. So in moving tracer, beam forces, say 1813, just a random number, not a random number. This is the number where maximum movement can be observed. So now another questions. Is there any way we can open files from newer version to older version of the software? No, unfortunately, we cannot open a new version file into older version. The reason is the new version is always have some additional updates. In order to open it to an older version, the syntax does not match with the older version. So newer version has an additional syntax which cannot be deleted or eliminated, ignored for the existing older version. Therefore, it is not possible in the reverse way. Sorry, thank you. Okay, thank you, Abdul, for sharing the ticket number. We'll get back to you by following up the issue over here. And yep, thank you everyone for attending. See you soon tomorrow. And Eric, if you have something to say, please, over to you.
Yeah, as I mentioned and Pranav mentioned, there will be the design part continued tomorrow, and also there will be another training session tomorrow focused on the plugin. So thank you for joining today, and if you have any further question, please feel free to reach me out anytime. And see you in tomorrow's training. Bye, everyone.
Bye everyone. Thank you.
Thank you very much.